of all of the markers on campus? How likely would you guess? Like,
Very.
what?
I said very unlikely.
Very unlikely, okay? And this is statistical speak. We use the words unlikely, likely, probably, probably not, improbable. So it is unlikely that this is a good representation. Why? Someone said something? Yeah.
Because the sample is so small.
Yes, okay. So the sample, so this is called this, well, obviously, the sample, okay? And so when we look at sample size, let's do, so we have 10, okay? So when we talk about sample, we always, it's always symbolized by an N, okay? So when I say we have an N of 10, then you know that there are 10 markers, okay? If I say we have an N of 30,000, you know that their entire number of markers that we're looking at is 30,000. But when we're talking the population, it's a capital letter N. Okay, so here's a couple more symbols that we need to keep, make sure that we know the difference, okay? Capital letter N is for population, lowercase n is for sample. Now, this is a big, big deal, okay? So the bigger the sample size, the more likely it is that the markers are going to represent the color, I guess we'll go with color at this point, color of all of ASU's markers. What if I added, what if I had 100? Would it be a little more likely?
Yeah, more.
Right, what if it was 10,000? 20,000? 28,000?
Very likely.
30,000?
Is there exact representation?
Yeah, it would be an exact representation. That very rarely happens, if ever, between a sample and a population, okay? But our job as statisticians is to determine if whatever change that there is, whatever difference there is, if that's a true difference or if it's a difference due to something else. So if there is a difference between the markers that we have here, okay, and the overall population of markers, okay, why? We just answered a couple questions. The sample size, okay? There might be another answer. Maybe this particular building only has these colors. You know, maybe, who knows? Okay, maybe there's more pink and purple and browns in the rest of the university. Okay, so it kind of depends on who bought these. I don't know who bought these. Are these from teachers that come in and they just leave them here? Or does this building or the department come in and they, you know, put these here? We don't know who put these here, and whoever put these here might have a favorite, a preference for the color of markers. Okay, so there's a lot of factors that we have to keep in mind when we're talking about those differences, and that's very similar to what we're going to be doing when you're looking at sample and population and inferential statistics. Okay. So if you ever want to increase, if you ever want to make your sample more likely to generalize to the population, and if you do, that's a good thing, because then your results will more likely be what we call significant. Okay, then we want to increase sample size. Okay, and then we're also going to talk a little bit about sampling error as well, which includes sample size, having a small sample size. Okay, great. I'm so glad that that came up. All right, I know you guys can't see this very well, and we could probably just throw this guy away because it's really light. But this is a bag of M&Ms. Okay, and so someone takes out a handful of M&Ms. Okay, great. So. Can you explain this? Who drawn it? Sorry.
Yes.
Yeah.
The handful of M&Ms is the sample, and the bag of M&Ms is the population.
Great. Okay. So let's go a little bit further. What color of M&Ms are in here? And I don't have So let's say we have red and green and blue. Okay. I'm ruining your picture. I'm so sorry. Now you're upset.
You're making it better.
Okay, so so we have these three colors. Okay, so we hope that we're going to have perfect. 1, 2, 3, 1, 2, 3, and oops. Horse or green. So when we draw when we sort of blindly draw out of the bag of M&Ms, we're going to hope to get, we draw 9, right? 3 red, 3 green, and 3 blue. Because that, if each of these represents a third of the of all the colors, then that would be great. That would be very representative. Okay, but sometimes we might draw red and 1 blue. Okay, we didn't mean to. We just stuck our hand in the bag, and that's what we got. It's random. Okay, so there's a chance that we could do that. Which chance is more likely to grab a representative group or to grab a non-representative group? Representative group, as long as there is a large N, as long as if we took a whole bunch of the M&Ms from there, it's going to be quite representative. Okay, but the smaller the sample, the less likely it is. Okay, so so really good. And this is inferential statistics, what we're going to talk about today. Okay, so good job, you guys. Did you write those in your notes, or did you write those on a separate sheet of paper? Notes? Okay. We don't need to turn them in then. I don't want you to ruin your notes. We'll turn something else in today. Okay, questions? Okay, so the symbols that go along with a population are called what? So if you have a value of any kind, all of those values are called what when you're referring to a population? Parameter? Hey, parameters. And if you refer to a sample and you're talking about any value, what are those values called? Yep. Is a statistic. Okay. What are examples of parameters?
Standard deviation is mean.
Yeah, standard deviation. I'm just going to start drawing the samples. Standard deviation, mean. Okay. We just stick with those. What about statistics? What was that? The acoustics in this room are terrible.
Sorry. For the mean and standard deviation, it was M and a lowercase s.
Thank you. Yep. So mean is capital letter M and lowercase s. Okay. So population. Oh, I'm sorry. I'm going to do these. Mean and standard deviation. Mean and standard deviation. And remember, if you're looking like online or something, or another textbook or something, you're going to maybe see X bar as the mean for the sample, but in our textbook it's this. Okay. All right. So I want to look at the two, say the two major types of statistics on a very broad spectrum, the descriptive and inferential statistics. So a third of the class will talk about descriptive statistics. 2/3 of the class will talk about the inferential stats. So in other words, we have 3 tests. The first test will be over descriptive, and the last 2 will be over inferential. Okay, so we'll talk about what those are first, and then have a better understanding. Okay, so statistics, all right? So statistics are tools to answer questions about certain phenomenon or variables, okay? Like, is there a correlation between color of hair and wearing glasses, okay? Is there, is there a relationship between having freckles and shoe size, okay? So those are really kind of crazy correlations and questions, but we need to use statistics in order to answer those. A statistic for those questions would be a Pearson correlation coefficient. That's the name of a statistic, okay? If we're looking at the differences between males and females in here as far as, amount of alcohol. Oh wait, you're freshmen, so no. Amount of caffeine drank every week. Do males drink more than females? Okay, that's what we would call a T statistic. Okay, so we're comparing. So there's different types of statistics based on the kind of question. So those things are going to go hand in hand. Now, my question to you is, what do you think descriptive statistics are? Can you give me an example or a definition or a phrase or a sound you would think descriptive statistics are? Just some kind of response. Yes?
When data uses like qualitative like words and descriptions.
Okay, so sometimes descriptive stats use words, and we're going to talk about that on Thursday when we look at scales of measurement. Right, so it's something that describes something, describes a value or describes, a variable of some sort. Anything else? Okay, so let's look at okay, you guys can see that. So these are procedures used to summarize, organize, and simplify data. And so when I say statistical procedures, usually that refers to, like I was saying, like the correlation or sort of inferential types of questions. But what I mean here is, more like values, okay? Or more like, of course, things that describe or summarize big sets of data. So what might be an example, what kind of value might be an example of a descriptive statistic, something that summarizes, organizes, or simplifies data?
Average statistics like in sports.
Oh, yeah, that's great. Okay, so you said average, ding, ding, ding. Okay, that's a mean. Okay, and I love that you added sports too. So we have averages, like batting averages. We have lots of statistics for sports. If you look on ESPN, it's constantly, right? We're constantly talking about the stats. And so the average for sports, means, okay, in other words, means. What about description? Yes?
I was going to ask, would something like a metadata analysis count? Or would that be more as inferential? because it's kind of like summarizing a group of studies, so.
Oh, okay. I'm going to put that down, but I'm going to, what's metaphysical? Meta-analysis, but I'm going to just kind of what that is. So instead, this is a big, I'm going to say a bunch of okay, so you could say that you take all these research studies and you're wondering about caffeine and ASU students, or maybe college students in general, and they're college students from this college and that college and this college and that college, and so you have all of these results from all of these research studies, and so you run what we call a meta-analysis. It takes all of those. It looks at different properties and excuse me, characteristics and the different statistics that are used to calculate those results, and then to come up with sort of some big results, overall results, okay? So, however, we are not going to talk about meta-analysis, but the same concept is true, all right? So we have averages, we have means. What other kinds of descriptive stats are there? Oh, I erased it. Range.
We can find a mode,
Oh, what?
a mode of data.
Sure. And we're going to talk about these in a second. Mode.
Median.
Median. Oh, here we go. And I'm just going to write this down. Mean. Okay? Mean, median, and mode. What else? Someone, I know I heard a yeah.
Standard error.
Oh. Have you ever watched or seen a weather report? Okay. That would be an example of a descriptive statistic. So how is that like a map of the amount of rainfall happening like right now in the state of Washington? Okay. How is that a descriptive statistic? We're measuring, right, every place, the amount of rainfall, okay, that is happening. Now that's a lot of data, and that's a lot of changes occurring, okay? So if like here, it rains and then it stops, rains and then it stops, and obviously there's, different amount of rain that we have in different areas. So instead of saying, okay, in this square mile of Washington, right now, this is how much rain there is. In this square mile, this. Instead of that, then we're going to instead take averages. So on average, in this region, we're going to say this is how many inches of rain we're getting right now. Okay? So it takes this like mind-numbing amount of information and data. But we don't have time. We don't have the capacity or energy to get anything out of that. So instead, we make it small by getting it into one number: standard deviation, mean, median, mode, pictures, graphs. Okay, so all of those things would make are descriptive statistics, all right? So I just put down a few of these, which you guys already mentioned, mean, median, and mode, so measures of central tendency. So how are you guys gonna do on your first test? You're gonna end up with an average. It's gonna tell me something